So, in the last video, we have discussed about the definition of workability and the factors that are influencing the workability. In this video, we are going to discuss about the measurement of workability. Okay, so as I told you, we have a workability which is low and we have a concrete which has a workability high. So how do you measure that? Measuring is important, right? You cannot just simply see the concrete and you can say that it is workable and it is not workable concrete. So what we do is we use certain tests in order to find the level of workability, and based on those numerical values of the workability you decide in which case it is good to use. Okay, so in this test, what we are going to do is we are going to give a numerical value to the workability. Okay, workability ni చెప్పాము, it is difficult to define. So when it is difficult to define, it is also difficult to present it, express it, right? దాన్ని కొలిచి చెప్పడం కూడా ఇబ్బంది. సో వాట్ వీఆర్ ట్రైంగ్ టు డూ ఈస్ వీఆర్ ట్రైంగ్ టు గివ్ ఎ నెంబర్ టు ది వర్కబిలిటీ. So we have four tests here. First one is slump test, compaction factor test, and flow test, and VB consistometer test. We can use any of these four tests to measure the workability of concrete. Of course, there are certain limitations. Something like for slump test, when the concrete has a little bit of fluidity, it should have certain fluidity in order to perform slump cone test. Okay, it should have certain fluidity. And compaction factor is used for low water by cement ratio. And flow test, very high water by cement ratio. Okay, so based on the water by cement ratio of the concrete, you decide what kind of test you wanted to use in order to give a numerical value to the workability, right? So the first one is slump test. So slump test is the most commonly used method for measuring the workability of concrete. Okay, this is the most commonly used method to test the workability of concrete, and it is not suitable for very wet concrete or for very dry concrete. That is, very wet ante water by cement ratio is very high, and dry concrete ante water by cement ratio is very low. సో వాటర్ బై సిమెంట్ రేషియో మరీ ఎక్కువైనా మరీ తక్కువైనా సరే ఈ స్లమ్ కోన్ టెస్ట్ అనేది ఉపయోగపడదు అనమాట వర్కబిలిటీ మెజర్ చేయడానికి. ఐ నీడ్ టు గో ఫర్, ఇఫ్ ది వాటర్ బై సిమెంట్ రేషియో వెరీ హై, గో ఫర్ ఫ్లో టెస్ట్, థర్డ్ వన్. అండ్ ఇఫ్ వాటర్ బై సిమెంట్ రేషియో is very low, go for compaction factor test, second one. Okay, the slump test will give you the one other important parameter, that is segregation. Okay, so once you see the process of slump cone test, you will understand that by the end of the experiment, the concrete is going to fall, and based on the nature how it falls or the deformation that is being shown will help us to decide whether segregation is going to take place or not. So this figure explains you the complete procedure of the slump cone test. This is the slump cone. This is slump cone. This is one of the equipment, and it is important to know the dimensions. Okay, it is like a cone, right? Top 10 centimeter, bottom 20 centimeter, and total height is 30 centimeter. And the other dimensions are as follows. So this is the shape, and remember the height is 30 centimeter, and this is steel rule, and this is tamping rods. So this is a tray. So what you are going to do is you are going to make concrete, prepare concrete, manufacture concrete, for which you wanted to find the workability of concrete. So what you do is you put the slump cone test in this orientation on this tray as shown in this figure 1. So what you do is you fill this concrete in the cone, but remember you have to put your legs at the bottom clamps so that this cone is not going to move when you are trying to fill the concrete. So you have to press it and you have to push downward so that it does not move. So fill this concrete in 3 layers. 1, 2, 3 layers. But remember, after fill, if this is 3 layers, I told you that the total height is 30 centimeters. So each layer has 10 centimeter depth. So 10 centimeter, 10 centimeter ki prati 10 centimeter కూడా మనం ఏం చేయాలంటే you have to use tamping tamping rod, and you have to tamp this concrete to remove the any air that is present inside that. Okay, so now this is the second layer and this is the third layer. So once you have filled everything at the top, the fourth step is పైన ఏదైనా ఎక్స్ట్రాగా మిగిలి ఉంటే దాన్ని మనం నీట్గా తీసేయాలి. ఓకే, సో ఎగ్జాక్ట్గా అప్ టు ది బ్రిమ్ టాప్ లెవెల్ వరకు కాంక్రీట్ అనేది ఇలా ఉండాలి. సో వాట్ హ్యాపెన్స్ ఆఫ్టర్ దట్ ఈస్ ఇన్ దిస్ ఫిఫ్త్ స్టెప్ మీరు యూ హ్యావ్ టు టేక్ అవే యువర్ లెగ్స్ అండ్ టాప్ ఏవైతే 2 హ్యాండిల్స్ ఉన్నాయో దాన్ని పట్టుకొని యూ హ్యావ్ టు lift this slump cone test. You have to remove that. You have to gently remove that slump cone. So what happens is, initially the height of this concrete inside this slump cone is 30 centimeters, right? You have filled the concrete up to the top of this slump cone, so it has to be 30 centimeter. But what happens is, it is going to collapse, it is going to go down, it is going to sink a bit. Okay, that is what we call as slump. So initially it is 30 centimeter, right? But it will be some height after removing this slump cone. Something you can say that it is 22 centimeter. 22 centimeter is the height after removing the slump cone. So how much height it has decreased is 8 centimeters. So 8 centimeter is what we call as slump of this concrete. So this slump value 8 centimeter is the value that indicates the workability of concrete. If the concrete is more workable, it is going to have more slump value. So if you can see this below figure, in the manner in which you measure the height of the slump. Okay, see in this concrete also. Okay, so let me give you a clear idea with this picture. So initially concrete is 30 centimeter inside the slump cone. So when you remove this slump cone, the concrete is going to fall down because it is going to spread down to the sides, and this is the final situation of the concrete. So now initial height to the final height, the difference between this is nothing but slump. Okay, of course you can see different concretes go show a different slump value. This is stamping rod by which you tamp the concrete prati 10 centimeter. So based on the value of slump, you are going to define concrete as low workable, medium workable and high workable concrete. As I told you, very low workability concrete ki ante very low slump ఉన్న వాటర్ బై సిమెంట్ రేషియో ఉన్నదానికి వెరీ హై దానికి ఎక్కువ ఫ్లూయిడిటీ ఉన్నదానికి మనం స్లంప్ కోన్ టెస్ట్ వాడలేము, సో వాడట్లేదు. సో ఇప్పుడు జనరల్గా మనం స్లంప్ కోన్ టెస్ట్ వాడితే ఇట్లాంటి వాల్యూస్ వస్తాయి. స్లంప్ వాల్యూ ఈజ్ గోయింగ్ టు బి ఇన్ దిస్ ఇన్ mm. Okay, this is 2.5 centimeter to 7.5 centimeter. So if the slump value is 25 to 75 mm, the workability of concrete is low, is set to be low. If it is 50 to 100, it is set to be medium. If it is 100 to 150, it is set to be high workable concrete. So in order to define the concrete as low, medium, high workable concrete by using slump, the slump value is the value that is helpful to me, right? And based on this slump, based on the degree of workability, you can decide where you wanted to use that particular concrete. And now I'm going to show you the procedure, the experimental procedure of slump cone test, so that you get a bit more clarity on how to do this slump cone test and how to measure that value, slump value, and how to define the concrete as low, medium and high workable concrete based on slump value.
Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel tamping rod of 16 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth, horizontal, rigid and non-absorbent surface. It is then filled in 4 layers, with the thickness of each layer being approximately 1/4 of the height of the mold. Each layer should be tamped 25 times evenly using the rounded end of the tamping rod such that strokes are uniformly distributed over the cross section. After the top layer is tamped, the concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibrations and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may either be a true slump, a shear slump, or a collapsible slump. The true slump is the desired form of slump that we require. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a shear or collapse slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can also be varied by changing the proportion, size and combination of the various sizes of the aggregates. It is advisable to assess the workability of concrete mix using a slump cone. Ensure that the cone is filled in a proper manner as indicated. Notice the type of slump. Shear and collapse slump are undesirable. Adjust the slump to the desired value by changing the proportion.